Hi, my name is Dr. Niall Burke, and today I'll be talking to you about the course, the Mechanical Engineering and Renewable Energy program in Athlone Institute of Technology. The course entry requirements from the CEO from 2020, the points requirement was 228. What was required was a grade 6 at ordinary level in 5 subjects in the Leave Insert exam. 2 of these subjects must be mathematics and a language. For QQI qualifications, any level 6 qualification must have one specified mathematics module included in your award, either the module mathematics or maths for IT or maths for STEM, or alternatively have the Leave Insert maths. So why take this course? On With our close relationship with industry, it ensures that our programs have a very practical and applied focus that will give you hands-on experience of the areas that is most relevant to today's industries. AIT's state-of-the-art engineering and informatics building is recognized internationally as housing a wide array of the latest equipment and technologies used in industry. This Bachelor of Engineering in Mechanical Engineering and Renewable Energy programme is fully accredited at associate level by Engineers Ireland, ensuring that you as a graduate can be confident the skills and knowledge you gain will be internationally recognised. The facilities of AIT are world class, including, for example, the sports arena that we have, but also the engineering building is a very new, very state of the art teaching and learning facility where all aspects of mechanical engineering and energy is covered with hands on experiences. So, what will you experience on this course? Engineering education at AIT is very practical, with almost 50% of your time spent in state of the art laboratories, developing your practical engineering skills. The other 50% will be spent on engineering theory and its application. You will work on topic specific problems both as part of a team and as an individual, and develop your lifelong learning skills. Upon completion of this program, you will have developed an ability to critically evaluate and examine mechanical engineering systems, identify areas of potential improvement, and be also able to implement solutions. So, what are the key themes of study? Well, for this 3 year level 7 program, the key themes that will be conducted throughout the whole program are included in energy science, workshop drawing in CAD, mechanics, materials and processes, computer applications, engineering mathematics, team engineering projects, and last but not least, the soft communication skills required to be able to deliver an understanding to these themes. So these are the core skills developed as a mechanical engineer, the ones that will be most valuable to you. So in addition to the core skills that you will develop, you will also develop skills in renewable energy. So the renewable energy subjects that will be covered on this program in 3rd year would be solar energy systems, which will include solar thermal systems, solar photovoltaic systems, which produce electricity from sunlight, and also ground and air source heat pump systems. Other modules then are combined heat and power, energy and sustainability, wind and hydropower. So these are the renewable energies you will gain knowledge of on the program. They are in addition to the core skills of mechanical engineering that you will have attained as well. So these are add-on and additional components that you will gain knowledge of. This is one example of a lab experiment that will be conducted as part of your solar energy module. It's where you take a solar thermal panel, which in this case is an evacuated tube panel, and evaluate it to determine its efficiency. This is a lab experiment, so we use artificial light to be able to produce artificial solar radiation, which then gets converted into thermal energy, and we see it as a useful energy coming out of it as how you would take a real system and determine its performance.
We'll also be testing solar PV panels for their performance and efficiency as well.
Labs and practicals are a big part of what we do, as explained earlier, and these hands-on laboratory experiments are conducted on core engineering principles and systems throughout all modules on the course. For example, going from left to right, we have a wind tunnel where we would evaluate aerodynamic systems. We also have fans and pumps where we evaluate their electrical efficiency and performance. In the middle, we have a smaller wind turbine or a wind tunnel, which will be evaluating a small wind turbine, and in particular, in this case, wind turbine blades, and how those blades and blade designs affect the efficiency of converting wind energy into electrical energy. On the far right, then we have a solar, we have a PV, we have a CHP system, which is a combined heat and power system producing both electricity and heat from the conversion of a fuel into thermal energy. That fuel can be a biofuel producing producing electricity and heat. So these are a few examples of the labs that you would be conducting as part of your experience on the BEng in Mechanical Engineering and Renewable Energy course. So once we move on from those labs, what you've built up is an understanding of how all of those core skills come together. But the culmination of all those core skills coming together will be in an engineering project. The engineering project is a team-based exploration of energy utilised in engineering systems, allowing you to put to use the knowledge gained in lectures. So this is your third year final year project that you will be conducting. So keep in mind, you've been told things through lectures, you've been shown things in labs. This is the involvement, and where you get an involvement, you get an understanding. And keep in mind, the only source of knowledge is experience. So this lab or this engineering project is where you will gain that valuable expertise and insight. The projects are used for group work where you're tasked with designing, building and testing all types of systems for mechanical performance and energy performance. So this is a few examples of final year projects that were conducted by students where they built a few different types of longboard electric vehicles. They tested them for their performance in terms of their mechanical fatigue testing, but also their acceleration and their top speeds were also evaluated as part of the project. The projects are a great way then for the students to also get to know one another, and also then for you to pursue your own areas of interest within renewable energy. So you get to choose the project, you get to choose what aspect of the project you evaluate. In this case, the students were able to break it down into different components. Some students evaluating the source of energy for these systems, some evaluating the motors, some the gearing, some the braking, etc., etc. But these projects are all student-led, so the students are in charge of the whole process. You have a lecturer as an advisor, but they are just facilitating the process. These few examples you can see are an impressive visualization of what can be achieved when the enthusiasm that we see in the students for this type of work comes together with knowledge and combines to make quite an impressive final year project in engineering.
Students get to build things like this solar thermal system, and it's where they put their theory to practice.
So what is the teaching style? As you can see from the introduction, the teaching style is to incorporate as much hands-on experience as possible of the subject material being taught in lectures. Within lectures, interaction and questions are encouraged and help develop your communication skills. So what we have is the lectures with the labs, and then we have the more interactive projects. But the lectures themselves, they are not passive, they are more interactive than what you would expect. There's a lot of interaction that required where you would ask questions and try and get feedback from what you're doing and what your level of understanding is. So that is encouraged totally within the lectures in AIT. The mechanical engineering staff have expertise and qualifications up to and including PhD, with wide-ranging commercial experience, and are active in research, but are also engaged with the community and wider industry. As a holder of this qualification, you will possess the necessary practical and theoretical underpinnings to enable progression to our Level 8 one-year add-on honours degree in mechanical engineering or the honours degree in manufacturing technology at AIT. So with your Level 7 three-year degree, you can then move on to our one-year Level 8 in mechanical engineering. As a career mechanical engineering graduates, with the additional skills in energy you will get from this mechanical engineering and renewable energy course will open up career opportunities in building services, energy management, building energy evaluation, utilities engineering, process development and maintenance, system operation of renewable energy systems and their installation. That's on just on the energy side, but as a graduate with the core skills of a mechanical engineer, you will be opening up your world to a career in manufacturing, operations and processing, automotive, CAD technician, and also maintenance technician. Keep in mind you can progress then to the Level 8, but you can also then progress further into research, masters, or PhDs in engineering, worth keeping in mind for the future. If you have any further queries or questions, don't hesitate to get in contact with us in the engineering department, and we will gladly help you with anything you need assistance on. Okay, thank you for your time and thank you for listening. Goodbye.